f of 1. Look at what's right up there. It's going to be the integral from 0 to 1 of lowercase f of x dx, right? Plus what? F of 0. But it tells you, what does it tell you f of 0 is equal to? It tells you that, oh, that's the wrong color to highlight that with, sorry. What does it tell you in this problem f of 0 is equal to? That right there is equal to 10, right? So the first thing you need to find is the integral from 0 to 1. We'll look over here. What is the integral from 0 to 1? What is the area, quote, under the curve? And area is a poor choice because area we think of as positive. What is the net change from 0 to 1? -3. So in this case, you know, in this specific case, f of 1 is going to be equal to -3 plus 10 is 7. So that's where the 7 comes from. So if you want to find f of 2, what do you have to do? You know, capital F of 2 is going to equal the integral from 0 to 2 of f of x dx plus 10, right? So you go back over here. What is it from 0 to 2? What is it from 0 to 2? What's the area under the curve from 0 to 2? What?
From 0 to 2 would be 0, right?
It would be 0 because it's -3 from 0 to 1, and then it's 3 from 1 to 2. So overall, what's the net change? 0. So it's 10 plus 0 is 10. Are we okay with this? Do you see how this works? Yeah. Do you see how if you didn't have the initial condition, you wouldn't be able to come up with a number, right? If that question did not give you, let's say it didn't give you f of 0 was 10, what would you have to call that? You'd have to call it f of 0 what? Plus -3, right? What would this one be? F of 0 plus 0, right? You know, you wouldn't know that. That's where we get those numbers from. So are you okay with finding the other two? Now, when you have straight lines like this and you have trapezoids, should you be able to find the area of those things? Yeah. Yes, you need to be able to find the areas of trapezoids and triangles and things. If you forget formulas, just break it up into triangles and rectangles. Seriously, sometimes like, is it the average? I'm like, I don't know. I'm just like 1, 2, 3, 4, 5. There's a triangle. Like, you can do it. Yes, David.
But that one you can just like.
There is 1/2 4 times 4, right? Base times height, so it's 8 again. So the whole thing is, yeah, sure. You can also do a trapezoid. It's a trapezoid if you look at it sideways. Most common way people mess these up. What do you think the most common way people mess things up? It's not because you don't remember the area of triangles or rectangles. What was I about to do? I didn't write 8 originally. I wrote 4. Why?
Just because 4 times 1. You thought it went up 1.
Up 1, the scale, right? Make sure you understand what the scale is. It's not always going to be the same. Let's do this. Just so 10. Here we go. So more fundamental theorem. Let's learn here. So this is what you focused on so far. This is what you've looked at. So we were just doing this right here. We were just doing this, right? But instead of it calling it capital F prime, we were just calling it lowercase f. So it's commonly referred to as this. Lowercase f is equal to capital F prime. Why don't I really like that notation? Can you tell me why I don't like it? I don't like using multiple
different variables.
Well, it's not even different. It's this, you call them the same thing, right? I don't like that. You know, I want to make it a little different. So I kind of like this better. I kind of like that better, but it's the same idea. We were just doing that, right? Without F0, we weren't able to find the overall where the position was. Okay, so let's say I give you this right here. It's a whole chart right here, whole chart. The integral from 0 to 4. If I wanted to compute the 0 from 0 to 4, what is that equal to in terms of a statement? That's equal to what? F what? We just did this. No, F0 plus the integral from
0 to 4 of f.
Yeah, what is this? Oh, wait. Okay, hold on a sec. This is the integral, so it's going to be f of 4 minus what? Yeah, I know. I'm going back to it. F of, I know. Sorry, f of 0. So do we have that information in the chart?
Yes.
Is that information there? Yeah, it is there actually. So does it tell us what F4 is? What is capital F4? Capital F, -7 minus what's capital F of 0? Is equal to? Yeah, -8. So sometimes you have a chart that will give you enough information directly, right? So what about the average value of F from 1 to 5? What's that statement? That would be, what statement are you trying to evaluate if you want the average value of lowercase f from 1 to 5? First you have to calculate the what? You've done this a bunch of times. This is not new. The what? Yeah, so we call that the integral from, not from 0 to 5, 1 to 5 of what? Lower or uppercase?
Lower.
Lowercase f of x dx. And what do you put out front? What did we put out front? What goes right here? 1 over what?
4.
1 over 5 minus 1. I just want to put the whole thing out there, right? So this is going to be 1 over 4 times, well, if we want the integral from 1 to 5, it's what minus what? What minus what for the integral from 1 to 5? F of capital F of 5. You see why I don't like that notation? You say F, and I'm like, which one? Capital F of 5 minus what?
Capital F of 1.
So, exactly. So do you have that information on the chart?
Yeah.
You do, actually. So it's going to be 1 over 4 times its capital F of 5.
Negative 14.
Negative 14 minus
2.
2? So what do you end up with there? Negative 16 over 4 is?
Negative 4.
Negative 4. Negative 4. So do you see if I give you a detailed enough chart and ask you the right specific integrals, can you, yeah, you can just use the chart. So this is comprehension. This is just comprehension. There's no actual